and it's time to start. So welcome everyone, good afternoon. This is the first Nmrg session for this afternoon. We have a second session at the end of the afternoon. I will start with giving a short introduction. We have a full agenda today, so I will ask also the presenters to be on their timing to allow maximum discussion for today. Can somebody also close the door, please, in the back of the room? Thank you. So starting with the notewell, so the IETF follows the IETF policy, so please be aware of the different recommendations in this notewell. By participating in the IETF meeting, you abide by these recommendations. And before we start the actual discussion, technical discussion, we need at least 2 persons to volunteer for being a minute taker and another one for being the Jabber scribe, Miteco Jabber scribe. So we cannot start without having at least 2 volunteers for that. Somebody for the minutes and somebody for the scribe. Yeah, please. For the minutes, thank you. And we need still someone for the Jabber scribe on Miteco. Will? Okay, thank you very much. Thank you. A quick highlight about the different things we will have with Nmrg during the IETF week, even if it's already close to the end. But we have this session 1 today, which is a kind of, I would say, regular Nmrg meeting, which we try to cover the ongoing and future items of the research group and also some status. We have a follow-up session, the last session of this afternoon, which will be a bit beyond the Nmrg, but still hosted by Nmrg. It's IETF special session on the AI and ML in networking. This will be a more kind of discussion meeting to understand a bit more the relationship between the networking part and the AI ML part and what we could derive from that either in IETF or more especially in IETF. And then also an announcement for an interim meeting of Nmrg. So on Friday, tomorrow, we have a 1-day meeting workshop dedicated to intent-based networking. The meeting will not be in this hotel. It will be hosted by ETS, École de Technologie Supérieure Montréal, which is 2 blocks away from here, so a 9-minute walk. All the information, all the details are on the mailing list, or if you are interested, please, at the end of this session, you can come to discuss with me. And Faten, which is also here in the room, will be our local host and help me to co-organize this meeting with a great help. Thanks, Faten. Quick outlook of our agenda. So this is the introduction, and I try to group the different presentation of today under some topics, so it's sometimes not always the right way of grouping, but the first topic will be around aspects pertaining to telemetry, with the first presentation from Pedro on exploiting external event detectors and their use to do some management activities. The second presentation will be from Aoyu on the network telemetry framework that has been presented also in other groups, and understand what we can do in the scope of Nmrg around this telemetry aspect, and especially the more forward-looking activities. The second topic will be on the management aspect of network slicing. There will be 2 presentations, one from Alex on the management problem, or the problem of the managing slicing and the gap analysis. And the second presentation from Kiran, which will be presenting remotely on some use cases of network slicing. And finally, the last topic will be on so-called novel approaches to network management. It's a way of grouping different presentations. So we will have, I think it was Kimson, on the intelligent network management using reinforcement learning. A second presentation on a roadmap to a networkless world from Bingyu. Then a remote presentation from Jefferson on Autonomics 3.0. And finally, Alex Clem will give an update on the ongoing draft distinguishing intent, policy, and service models. Any comment on the the proposed agenda, modification? No? Thank you. So a couple of things I would like to mention on the status of the research group. The meetings planned for this year. So we didn't meet in IETF 101 in London because usually we try to collocate at least one of the yearly meeting with one of the scientific conferences in network management. This year it was with NUMS 2018 in Taiwan in April. So this is past. And we are currently having this meeting today. Tomorrow it's an interim still in Montreal. And the last meeting we will plan to have this year will be with IETF 103 in Bangkok in November. And in parallel to that, you can come discuss with the chair or suggest on the mailing list ad hoc interim or topical meeting. We used to have this, like for instance, tomorrow, the meeting on internet-based networking. So if you have any suggestion or proposal or things you would like to discuss, we are here to help. Status on some documents related to the research group. So recently in February, we had the new RFC published under the Nmrg, so RFC 8316 on autonomic networking use case for distributed detection of SLA violations. So congratulations to the authors, because it was a long-standing effort to get this published. This work initiated during the first phase of autonomic networking in Nmrg with the use cases that were expressed something like 3 or 4 years ago. And we still have also individual documents that are active in the group, and some of them will be presented in the follow-up slots. For those that are not fully aware, we built what we call a research agenda for the research group in order to organize the activities or the document in the group around a set of themes. Currently defined, we have internet-based network management, the use of AI techniques for network management, and another theme that we call for the moment autonomic 3.0 or self-driving network or zero-touch networking. So the idea is to understand what we could do in the scope of autonomic networking and new approaches to approach this environment. Of course, this is not limited to these 3 themes. Based on the presentation we can have, your suggestion, we can develop new topics for the research agenda. So it's based on the interest and its contribution driven. So if you have a proposal, we are here to hear you and give you a floor for some suggestions. Out of those, I will say, themes of the research agenda, the idea is to derive more specific research items, identify maybe documents, activities of the research group, experimental result or experimental validation, but also possibly also a work plan and some milestone. We understand that it's a research activity, so it's not like a working group where you have, I would say, more strict time management, but still, if we can derive some milestone for those activities, it's important to see the progress. And finally, if you want to read a bit more about the content of each of those themes, with Lisandro, we had published in March in the IEEE Communication Standard Series. There is some standard news, which are very short articles highlighting progress in different areas. And there is so a short article for Nmrg in this issue. I think it's freely available. Otherwise, you can just ask me. I can give you a copy. And just to mention also that there are also several others IETF activities and RITF activities that are reported in this March issue. Now a word on the so-called future of Nmrg. So I think for those that follows the mailing list, you are aware that Lisandro, my co-chair, decided to step down after 7 years of service as co-chair of Nmrg. So I would like to really address my thanks to Lisandro. Unfortunately, he cannot be here for budget reason, for all what he has done in the Nmrg and the interaction we had. The good thing is that Lisandro will still be an active participant of the group, not as a chair, but as a contributor. So we will not lose his good spirit here. But there are also 2 consequences or actions that we take after this announcement. So we searched for a new co-chair. So the call for candidates has already been sent to the mailing list a month ago, something like this. And we already have some candidates, but we are still accepting volunteers, and we will review the candidates with the IETF chair. The second aspect, and this is also following some discussion I had this week with the IETF chair, Alison, we came to the conclusion that it can be a good time also to use this opportunity, I will say, in the search of a new co-chair to rethink what is Nmrg and what will be the next step for Nmrg. Just for the memory, Nmrg started in March 1999, so it's, I think, one or the oldest research group still active in Nmrg. So the idea will be not to erase everything, but to reconsider, maybe to be a bit more in phase with the evolution of network management and the managed environments. So to capture maybe a bit better in the charter and the activity those new things, and also to use this effort to have a bit new ambitions, I will say, trying to highlight a bit more hot topics in the area of network management, but also understand a bit more some orientation towards what it means to manage or to operate at scale and at speed in those new environments. So this is ongoing work, ongoing discussions, ongoing thoughts. So we will propose and consult with the research group for a new name, for the scope, the charter over the coming months. We think that by the next meeting in November, we would like to have progress on this thing. We don't put ourselves a hard milestone to conclude by the next IETF, but still we would like to have started those these new evolutions. And of course, you are really welcome to send your thoughts and contribution if you have good ideas for the hot topics, if you want to candidate for new co-chair or any elements you would like to see in the future of this Nmrg. And a final note on that, for me, it doesn't mean that we get rid about the existing work. This work will continue. This is good work that is going somewhere, so we will keep this. The new charter will mainly focus on what will be the next stage of Nmrg. And I think this is my last slide. Any quick comments on the research group status before we switch to the technical presentations? Thank you. So I will ask Pedro to come for the first presentation.
Oh, okay. Good afternoon. I will just present the quick updates on the draft I already presented in the meeting of NOMS. And after that, I will give some hints about other topic that I want to discuss here in this room. First, the context of this of my draft, this and also this update would be, it is that to adapt resources assigned to a system to its dynamic demands in order to reduce the cost and increase the revenue of the system. Avoid discarding requests. That's important for service quality and essential in emergency scenarios, as I presented in the last meeting, and estimate and anticipate resource demands by considering internal and external information that can be used to avoid the need of over-allocation, and that is the result of normally conservative methods, so thresholds on some controllers, and achieve fast adaptation to bursts of the system. Well, this is the algorithm I presented, in which now I am concentrating in how to get this information from the external event detectors to the system. And I started this in this update by introducing the information model and in Yang, that is required in order to get that information. First, it is quite simple, but it is based on two models. There's the events and the notification. The event one is based on payloads, and the payloads I have defined only 3 basic payloads. The first one is to to include any arbitrary information that can be useful from outside the system into the control plane. And second one is one example of one of these more specific payloads to get information from one seismometer, one sensor, about some tremors that can happen outside of the system, of course, and can be interested for the control management of the system. And the third one is the big data, that some big data analyzer can find some interesting information that can be used in the management of the system, and using this payload it can be introduced. And then we have also defined the information model, the event itself with all the necessary fields that are typically used in order to communicate those events. And finally, the notification, that is basically this using this structure in order to perform this communication as a notification that is, in this case, coming from outside of the system. Okay, so that's all for this update. If you want to check the draft, it's already there, and if you want to comment on anything, please. I will be open that in the mailing list. The second topic I wanted to discuss was about the essential artifacts that we require in order to achieve what we can define as intelligent-driven networks. Well, first, to clarify some concepts, I want to define that here, that AI is not ML. Normally, many people consider, oh, machine learning is a hype, blah, blah, blah. But yes, but AI has a broader spectrum. It is based on perception, reasoning, planning, and it is not fully exploited in the network, but it's already present in some parts. So we have not to be scary of incorporating AI, especially for network management, as I will defend later. Also, another concept is that intelligence is different from intelligent. That means that intelligence is more more broader terms that emphasize the gathering of the information and how and the management of that information. Intelligent emphasizes the smartness of one device. They don't have to be present at the same time. Or what I mean. So. Why applying AI?
I just have, Dan Bogdanovich, I have a question. Can you go one slide back? I'm curious you said which methods are already exploited, AI methods are already exploited in networks today?
Today? Yeah, I cannot give you all the list in my mind, but for example, any planning that you can be used, let's say, in a router. A router is constantly checking the best route from point A to point B. If it is taking some heuristic in order to determine that, for example, in geographical routing or something like that, that heuristic is part of AI. Well, no, I want to point something.
Okay.
No, sorry, I want to point something. Normally, the definition of AI in my field, in my experience, according to years, is everything that is not being used today. If it is used, it's no longer considered AI because it's used. Normally, it's that. There are many, many, many methods that are actually AI that are being used today, but they are not considered AI, but they are actually. I'm sorry. about
Okay,
that.
that,
As I was saying, is that why applying this deep application of AI into the network management is because management decisions are, as we know, are becoming more and more complex. For example, I have one mention is that before we had to answer the question, is there a problem in my system? But today, the question is more broad, like, where should I migrate this virtual machine according to my goals? And the goals can be very complex. So, and that must be resolved automatically for thousands or even more elements at the same time. Well, also, the operational environments where the systems are working are more and more dynamic. And this is emphasized by softwareization and programmability, and network virtualization and automation are required for that. Also, we have that network devices are becoming autonomic, as we have here also in IETF with Anima, etc. And there are complex decisions that are being taken, and zero-touch networks, for example, they have to fully exploit programmable elements. And finally, what is why not? Why not using AI is just a method and resources, not solutions. Solutions are made after that. Well, okay. Well, I will go fast in that part. So to exploit AI in this intelligence-driven networking, we have access, permit to that technology to have access to a huge amount of intelligence data from the system that they are managing. Okay, the knowledge derived from such data can be used to decide the strategic response on any event or situation. So finally, we have a constantly evolving model that we can, why not say, knowledge-driven network. Well, so this intelligence-driven network is the key factor there is that the structure of the network results from the reasoning of intelligence, from intelligent data. The network adapts to new situations, perceived and resonate from that data. And the data must be properly managed and exploited as much as possible. And the algorithms must be adapted to work on network problems, specifically on network problems. Today, AI algorithms are quite general and are not particularly specific for networking. And we have some use cases like predicting traffic behavior, iterative network optimization, or the assessment of administrative policies that is quite important in networking. So the standardization issues that are behind or emerging from this application would be to facilitate, in order to facilitate the coexistence of methods from different providers vendors, would be that the methods used to retrieve the information must be, the quality of the methods must be assured. So we have to assess the quality of the method. So when user, no customer or whatever, they can check if one method is better than other in some terms that can be validated by that stakeholder. Also, the types and quality of information that is retrieved from a system or object must be consistent. Consistent in terms of that if we are receiving one measure
data to support AI-based solutions.
There is no single open source data available now.
Yeah, yeah. So I believe for the different plane, we may have a different situation. For the control plane, we may be able to directly monitor the interactions of routing protocols, and we also already have a lot of database for the managed plane data, and also to monitor the user SLAs, and we are, the operators is able to pin down some user flows to monitor their performance experience. So I think we, as a vendor, we can provide the technologies, and the operator can take advantage of these technologies and to extract data out of their network to achieve different applications. I think that's possible.
It's not a problem, Dan Bogdanovich. It's not a problem in the possibility, it's a problem in the willingness. And my other question is, that was a comment, and my question here is, what are you missing in the existing technologies that you have today that you cannot develop to collect the data from the network?
What's missing? For example, we talked about with several operators. They said they still prefer to have some unified interface for the data collecting, and but now
you cannot unify. Let me answer this. You cannot unify different types of data in a single database because they have different characteristics that you cannot put in a single database. You have to have multiple different databases. One has to be chronological, and the other one will be not transactional.
Yeah. I mean, that's a different layer, right? You are talking about how the data are organized for the application, but there are also interface how the data are extracted from the network devices. So currently there are multiple different proposals, and maybe we don't try to unify to the single interface, but at least for each plane, it's preferred to have some sort of one or two very few standard interface, so they don't need to talk to many proprietary.
In my opinion, it's important to understand the data, and which interface it comes over. It is much less, because what we have today might not be sufficient tomorrow, and the data has to be consistent, but the interface is more or less, and it can be adapted, that could be changed.
Okay, thank you. One last comment, please.
Hi, Manasi Deval. I think there are a couple of things I'd like to point out. Telemetry means different things at different layers.
Yeah.
So if we look at it at the bottom, we're looking at bytes and packets per second kind of a thing, maybe related to a single connection, like a per connection information.
Right.
But very quickly it becomes a response time calculation for HTTP, or it could be responsiveness for some other application. So at different layers, it means different things.
Right.
And then there is also an inherent security associated with this data, which I think may not be fully captured in your talk.
So what's your second point? What's not captured?
There's a security aspect of
Security.
this.
Oh, yeah,
Yes.
yeah.
So
You mean for security purpose, or some security mechanisms to support the telemetry data?
So there is an aspect of who can see this data.
Okay.
Right. And I think if if you're creating a protocol or interface, whatever that might be, that would be the thing to look at.
Yes.
But the question I had was actually similar to the previous speaker, in terms of, do you know exactly what you're missing right now in terms of telemetry data? What is it that anybody needs?
So there are some ongoing work here actually try to address those issues, like the in-situ OEM, right? It's try to provide the real-time traffic performance measurement for user flows. So that's not available today, right? And that's just one example. And there may be some other works. For example, for the we are doing some work on the control plane monitoring. So we try to extend the BMP protocol to support more thoroughly control plane measurement. So there's some ongoing works, but they're not existing today. So that's why this work we want to identify what's missing or what's the gap. Maybe some new stuff is still needed.
So right now, what is being used in the, what you can get are counters that hardware vendors would set up in their devices, right?
Yeah.
Is there something missing in that list of counters that you have?
There are a lot of counter resources available, but for example, if you want to get some statistics for some specific user flows, it's difficult to do today because there are limited resources, and sometimes you may need to dynamically, interactively allocate that resource to designate what flow you want to monitor. So that's something we also think is new.
Thanks.
Okay, just commenting as myself. One area I think that is, where the research group could contribute or work on is the aspect of metadata, because I think we already have quite a lot of data and measurement protocol and whatever. But as Dean pointed out, it's to understand this data. Usually there is a challenge to be able to describe metadata so that this can be used by other application or analytics in the pipeline to understand the data that is coming, what is it, and how it can be exploited by more intelligent, with what Pedro mentioned, intelligent mechanism at the end of the chain. So how to attach those metadata or to describe them, I think it's something that is not so much down today on these telemetry aspects.
Yeah. Okay.
And also, I think usually there is the aspect of correlating multiple sources. Usually you can get one flow of data. Protocols are designed to get one source of data, the data they expect to have.
Right.
But if you are also a capability to, if you have multiple sources, you can collect data from multiple protocols, multiple points.
Right.
There is also the aspect of being able to get those multiple sources and correlate them to get a different understanding of what's happening from multiple point of view, either different dimension or different endpoints.
Right. That's a very important. In our framework, you do have the data source from different plane. Also, in the same plane, it can from different devices. You do need to correlate all the data for some applications. We actually are thinking about some real use case to support that kind of a correlation.
Final comment.
I was not sure they were going to close the developers Telefonica. Looking at this, I think I agree that there is some need of work here. What I'm wondering is whether what we need is, because there are already several protocols around and mechanisms for exchanging data, measurements, and all the like, and there's work ongoing around in the IETF and elsewhere doing this. You have, for example, just the BMWG that is dealing with measurements, or previous works that was made for, I don't remember the name, for IPFix, if I remember well.
Yeah.
Things like that. What they miss, and I think this is important in that direction, would be precisely a mechanism for not trying to build a theory of a unified protocol for everything, but a mechanism for managing data. For managing metadata, how you can a certain element that is going to consume the data that is coming from whatever the measurement points, is able to know which are those data and how to process them.
Yeah.
I think that if we can move forward in a way in which we would facilitate the measurement points, the way in which they can declare which data they're going to provide, and on the other hand, the others to announce which data they are trying to consume, that would be an advantage. So that's more than, I mean, to my views, that would be more important than defining another architecture. But that's probably is making it more data-centric and less, let's say, node-centric.
Yeah. So you can see maybe what you said is mostly the last components about data analytics and storage, but that part is current is a little bit fuzzy. There are a lot of existing open source tools and they are widely used.
Mm-hmm.
But maybe here in IETF we are more about the standard for the other components. As you said, for the data export, right? The data plane, we may use IPFix and UDP directly from the device forwarding path. And maybe for the management plane, we use gRPC and some other protocols. We don't try to invent news, but we need to identify what's available. And even for this existing protocols, what's missing. So that's the first task we want to do.
Yeah. Maybe that's precisely. I mean, maybe it's something about thinking or start playing with the idea in research terms to start with, on how something that would be similar to what Jan has become for management would be precisely how to declare the schema of data that you're willing to consume or produce. Just as a suggestion, is something that we could elaborate later on.
Yeah. Thank you.
We have to move on. Thank you for the discussion and the comments. The next presentation will be from Alex on the management slicing problems and gap analysis.
Thank you very much. How much time do I have?
Maximum 10 minutes.
Okay, I'll try to do it faster. My presentation focuses on some suggested future problems related to management, which may be over the scope of this working group. And I reflect the research management challenges rather than other engineering challenges which are related to the topic which I'm going to present. This was driven mainly and derived from a survey and a tutorial which I mainly put together and delivered 2 weeks ago, vis-a-vis of reviewing most, if not all, the aspects which are published so far related to the concept of network slicing in SDOs, in research environments, as well as in industrial context, as well as many other aspects. So that's the origin of it. And I will make some presentation, but also I would like to point out that there are some, in my view, some concluding remarks which may be of your importance. Next slide, please. By now, everybody should know that network slicing is now a concept which is now not on research, but it's engineered worldwide by all the players, as far as I understand, in some form of shape. It's probably, as a concept, is older than me, but it will outlive me by far. And the concept itself is not new, namely that the problem of network services is partitioned, if you want, in such a way that the infrastructure supporting it will be able to deliver or to support each partition, if you want, separately. So we're talking about multiple networks to be produced, conceived, managed, operated, as well as closed down in parallel and on demand. Just to point out that these partitions are not related to virtual networks or traffic engineering aspects or only VPNs, mainly because the concept of network slicing, as I understand it now, it's a composite of 3 elements, not 2, not 1. One indefinitely is the resources and network functions, virtual network functions, which need to be put together either from the network cloud or the on connectivity network, one part, but the other parts are the management function which you attach to it as a group, and more importantly, the services which will be delivered, at least one well. So these 3 have to be looked at one rather than separately as they used to be. This sort of concept appears to be very useful in a number of important scenarios which are now, as I understand it, driven from key requirements of the industry. There are many listed here, but one of the special one which I think that there should maybe one focus point is about the high precision service networks which are appearing, namely the possibility to create parallel slices in such a way that each of them to have a level of guarantees either for the quality of service or KPIs. It's inconceivable to have something new based on IP, because IP is not guaranteeing anything, to guarantee, let's say, low latency plus many other things for all the type of services. So it's a good idea to split, if you're on the problem space, and to understand how to do this well. Therefore, this is fundamental, but it's something practical as well. In addition, there is another practicality of this splitting, is that some of these IETF protocols could be deployed in a slice. Most of them cannot be deployed at large because it will involve too many nodes to be changed worldwide, which is too expensive. Okay, in this review there are many frameworks which are suggested. Few are presented here on the left side from at IETF. Second, on a research project mainly dealing with the network clouds. However, the things which I'm promoting is that this new, relatively new emerging concept has its own management problems. And I'm listing them, and although I'm not going to go through all of them, just saying that they need to be resolved. Without the management elements for this network size, the whole thing will stand out. Some of the tools are in place, but there is no single bullet to solve all of them. In particular, the fact that these are autonomic operations and we cannot scale it up without autonomicity, and many other things which are listed on this chart. Or the next, and very importantly, is to understand the intricate relationship between service and data services mapping into these containers to make sure that this is practical. In addition, that the problem of how you compose, decompose on demand, and how to do all the other things are listed important. In addition to this detailed one, I would like to add 2 more, namely about the way in which network slicing could be scaled up, in particular management scale up, not to tens, but to maybe 10,000, maybe millions of possibilities. The practicality of it, as well as how you perform it, it's probably a key research topic now in the future as well. And also how these slices could be used for precision service or network services. Now, I point out one thing, which is it might be that the networking element of the future will be based on slices. There will be many types, and they are supported by an underlying lightweight mechanism to make the existing network fabric a bit more soft, but also, if you are controlled by the management, which is in slice management, as well as overall end-to-end orchestration, which need to be done. Therefore, there is a shift. And once you are in this transition, it's a time to move towards it and try to take advantage, and research problems will appear automatically. Not as a framework, but in some specific areas. Now, clearly, this is a scope or problems. These problems are in the scope of Nmrg. So I'm suggesting that maybe you need to look at it, and your feedback will be highly appreciated. And once again, just to say that this material is not driven by one RFC or many, but is a way to present some, but a longer list, the management problems which need to be resolved here, as well in other parts, some engineering problems as well. That's for sure, but before concluding, part of this tutorial, which I presented 2 weeks ago in Montreal at the academic conference, I included around 100 academic references, but also a roadmap of existing references of work in slices, which is listed on this. That concludes my presentation. Now it's your turn to knock me down. Thank you. Or not.
Dejan Bogdanovic. So network slicing is an interesting, management of network slicing is an interesting problem. And I spent personally and within my work time thinking about management of the network slices of the control and management plane. But I'm still struggling to get what would be definition of a network slicing in a data plane, because whenever I hear data plane, I'm hearing different interpretation, and they all start dedicated network resources are too expensive. So I'm thinking, are we talking about, the lambdas in the optical layer? Are we talking about, VLANs? Are we talking about, how do we want to do network slicing in the data plane? Then we can then map that slice to my control plane slice and make sure that I can manage those resources in parallel.
Good question. You want an answer? Or you have an answer?
I don't have I have some ideas, but I'm curious to hear, in this case, your opinion, because everybody, yes, they in the T's, and I'm always saying dedicated network resources are too expensive. We all know that. But then how do we define the slice in the data plane?
Okay, thank you. The question is extremely valid, but my suggested answer is that the current important topics about how to manage and orchestrate this new, relatively new concept now in this form lies with the management and control plane and service plane, obviously with an interaction between the three and a footprint in the data plane. The data plane does not dictate this. And I'm fully aware that there are maybe around 7 or 8 ways to activate as a data plane the slices, if you want. But this is to some extent not the essence now, mainly because an operator, like British Telecom, the guy was here just, or anybody else, has its own way to organize their resources. And they will not accept one of the 7 under current things like, I don't want to name a few, and they organize it. So the issue is, or the current problematic area is in the management plane and interaction with the control plane and service plane, and to act as one and bring it down later with some ways to link it with one of the many or all the way with all the things related to data plane instantiation. If you start from the data plane, for example, from the segment routing, you'll end up with not much, because segment routing will not be applied to all the parts of the network, as well as other things. Therefore, I would suggest that the priority is to, with a management plane problem first, and then map to a number of options for the data plane.
Okay, we have to conclude this discussion. I don't know if you want to reply quickly, Dean, or no? Very quickly.
We can wrap it. So.
Okay, so maybe follow-up discussion. Now it will be Kiran on a remote presentation for the next, on the slicing use cases. Not yet, it's the power of the chair. Kiran, if you hear me, you need to switch to presenter mode or raise your hand so that I can give you the floor.
Can you guys hear me now?
It's okay.
Okay. I'm hearing some echo myself. I don't know why. So let me get started. My presentation is slightly different from what Alex talked about. It is initially I thought we will talk about the use cases in network management, uh, network slice management, but it turned out to be a very high level overview of the work we have done in previous couple of BOFs related to network slices. Let's go to slide number 3, please. So in a very simple way, an informal definition of network slices would be how we build a how we build networks for a particular service with certain resource requirements and constraints. And we should be able to allow logical isolation of resources such as network, storage, compute, and maybe application service or other network functions. It should support multi-tenancy, and one of the differentiating factor is that these resources should be managed by the tenants themselves, not by the operator of the infrastructure. And then slices should also have some sort of dynamic capabilities if you want to augment the resources within a particular slice. So this is just an informal definition, because if you try to put it in one sentence, you can't finish it. So let's go to next slide, please. And so why do we want to work on network slices? First of all, we have to differentiate it from traditional VPNs, because that was one of the question that was raised in one of in first BOF of network slices. And we said that the kind of resource guarantees we want to achieve are at per flow level, and they are different from how VPNs are built. On top of that, we look at slices in terms of service verticals. We want to do end-to-end orchestration of all the different kinds of resources and be able to manage them in runtime. And then how network slices will be used. They will be provided as a service by the service providers or the infrastructure owners. And in order to do that in a repeatable and a standard manner, we need to have some sort of standard interface over which they can talk to different network components or management components specifically. And it should have customization capabilities and maybe some top level data models specific to services and the slices that can be broken down into control plane or the data plane related configurations or operations. And finally, for me, the most important aspect is to look at management of network slicing as a way of understanding slices from end-to-end perspective. Management plane is the only level from which we can look at end-to-end slices, how resources are allocated, abstracted, or mapped in the network. So if you talk in different working groups, they are looking at some functionality related to the slices, but it is very difficult to put it all together. And if we take up this work here in Nmrg, that's exactly what we can achieve, the entire management view of the slices, specifically in terms of OAM and FCAPS operations. Next slide, please. So when we were initially working on network slicing BOF, we first started with the functional aspects of the slices, and we classified into 3 categories. First one is pretty simple, related to customization, that an infrastructure provider will provide network slice as a service to enterprise customers, and exploiting the virtualization capabilities, you could allow enterprise customers to build their own VCPE or SD-WAN solutions by placing their network functions wherever they want to in their networks. The second aspect was the resource assurance, which most of the people always talk about, generally related to low latency, broadband, and MMTC type of slices. And then we also identified another category, which was how can you evolve new protocols in a given partitioned network. So this will be more like a low-level partitioning of the slices of the resources. So you could choose to run your own application protocols or maybe other network or control protocols given a particular set of network resources. But that work was considered pretty broad, so we just started focusing on the network management aspects. And from the management of slices, we identified that we would need some kind of end-to-end orchestration capability. We would need ability for tenants to customize the slices. We need operations and management of the slices, FCAPS functionality, and more importantly, how they will interoperate across multiple domains that are under the control of different administrators. And how would you interconnect parts of the slices that belong to different network? Next slide, please.
Kiran, you have 3 minutes left.
Okay. So this is the reference architecture where we talked about that an NS provider, which is network slice provider, will have a kind of northbound interface to the tenant, and it will have southbound interface to network slice orchestrators. These orchestrators talk to their own infrastructure. And at this point, when we're talking about management, we don't touch the control plane or the data plane functionality. Next slide, please. And we identified some of the key functions that will take place over these interfaces, which is describing your network slice as a service request, what kind of resource requirements and corresponding parameters you have, and how will you negotiate for a particular slice service, not only in terms of which subnet you want your part of your slice to be in, also the cost that will be some kind of cost negotiation with the infrastructure owners. And similarly, from the southbound perspective, we want to do the capability learning. We want to aggregate information from different subnets of the slices and put them together, map them to the tenant slices, tenant services. Next slide, please. So let's skip this part since I'm running out of time. Next slide. So the previous slide was just running through the use case, how SDI and CSI interfaces are useful in terms of entire flow of instantiating a slice. So from NMRG perspective, for me, the most important aspect is how do you see end-to-end slices from management plane? And how do we integrate the operations on the slices and the resources together? Some of the challenges with from management part is that we will always be challenged that there are so many Yang models available, which are service specific or infrastructure specific. How are you going to use them or exploit them, or are you going to write new models? So these are the questions we will have to answer and identify going forward. And of course, interdomain is one of the big part, and stitching slices across heterogeneous technologies will be another challenge. Next slide, please. So this is just my view, what we can do in this group, that let's not worry about the data plane and control plane part. Just focus on network slice as a service management aspect, define the service, provide the monitoring and performance capabilities, define slices as some kind of service graphs, and it should be agnostic of any particular architecture. Like, let's not think about NFV, SFC or anything. And because we need to be able to stitch all those things together. And we should be able to stitch together a part of L3 network with the L2 network. And it should be a very lean solution. Next slide, please. So this is my final slide. Main thing was to figure out that should we take up this work in NMRG? Is it a suitable place or not? And if this work is accepted, we would start talking about CSI and SDI in more details, and that would be a very good starting point. Thank you.
Thank you, Kiran. We have a few minutes for Dean question.
Yeah, Dejan Bogdanovic. I will rat hole again down on the data point. We always talk
Okay.
about resource management. What
Mhm.
about, how can I manage the resources if I don't know the capabilities of those resources?
So this is
Because
something,
different resources are using different, capabilities. That would be one of my questions. And then the second question, if you can go, please go to slide number 6. So, in the reference framework here, I have, essentially several issues. You are talking about the network slicing service, but where does your service model sits on this? Are you talking the this your infrastructure configuration model, or where's your service model on that part? And then the last part saying that data plane and control plane will be solved somewhere else without correlating, with that work. I don't think it can be very successful.
yeah, so let me answer your questions in the reverse order. It's simpler that way. So we have to start somewhere. What you have in mind is a bottom-up approach, which is perfectly fine. There's nothing wrong with that. But what we are trying to do is from Nmrg, we are taking a top-down approach, define the management aspects of it, and let's tackle the control and data plane issues. Those issues we have already identified in our initial gap analysis document. It's just that we haven't discussed it over here. If you look at the original gap analysis document, a lot of things what we wanted to do about data plane was highlighted there. It's just that no working group is willing to take that work right now. And in terms of service model, my perception is that my service model will be inserted from the CSI interface, and that's from where my service description will come into NS provider, the network slice provider, which is actually going to do the most of the heavy lifting for the network slice management.
Bogdanovic, could you just point on this slide 6, where would you insert the service model?
From on CSI tenant to provider.
Reza Rukui, the Nokia service model, the one thing that I mentioned also yesterday, in this picture, in my opinion, the most important interface which is not shown here is from orchestrator to the service. So basically, the model that we are referring here is not the service model, it's a connectivity model. This is a brand new model that I mentioned it to Alex yesterday as well. I'm working on it now, that basically the interface between orchestrator and infrastructure is a connectivity model, and from there is a service model. Basically, you receive a request that I want to connect a BBU to a gateway, and we translate that onto a service model. So if I want to start with this architecture, I start with that interface. In my opinion, is the most important aspect. The interface to the tenant is important, but it's not that important. So
I agree. I agree that interface from tenant to provider will be relatively lean, but the kind of service model you're talking about, for me, it resides in provider. It will be probably some other internal interface within NS provider.
But again,
Orchestrator
this
here
is
is
not service
specifically
model.
related to infrastructure. So NS provider is something at a level above the network infrastructure owners. It is collecting the capabilities from different infrastructures and kind of aggregating that information together. So
But then-
it does not own any infrastructure by itself.
Yeah. It's not service model, it's a connectivity model. I'm just stressing that one. So the second one is, and I see this one in various presentations on the network slicing, there are all the time they talk about end-to-end, but I never see end-to-end concept. Whatever they talk about is not really a network slice, it's a transport slice. We're just doing the connectivity at the transport layer.
Mhm.
If you want to address the end-to-end, I should see a picture that starts from the RAN and end at the EPC. And this is really end-to-end. And there are lots of aspects that is not, RAN slice and core slice, for example, 5G core.
So there is a little bit more history behind that. You have some kind of RAN and 3GPP network in your mind, and we were asked not to look into the 3GPP aspects of the slicing. So we look at just the transport network.
Yeah, sorry, but we had this power outage and we are really missing time. So we cannot solve all the discussion on network slicing and the management aspect of network slicing now, and we are really short on time. Just my comment as a chair is, currently I don't really see clearly what the research challenges are. So this can be worked out offline, the mailing list with presentation, etc. But there's still opportunity to express what really the Nmrg could investigate. So you can work all together on that. But we have to close this discussion now.
Yeah, but just a last comment. As far as I understand, in my presentation, I made a list of around 15 research challenges, management research. Now, if you believe that you don't understand them, that's your problem. But to say that this is it and we have to do something else,
I'm not saying this is it. I'm saying
a bit opaque.
No, the thing is,
Thank you.
First, we don't have time to go into more discussion.
If you identify a problem, the point of the research group and working groups is to find other people who understand that problem and help you rehash the solution of that problem. So if nobody understands it, we want to learn and understand what is the problem to help you solve that problem. Because many of us are working on the same or similar problems.
Yeah, thanks, Dean. This was also a bit my line that I'm not saying there are no problems. I think the way to present them and make people understand and adhere to the vision, it's still not there. So we had this first opportunity to discuss, but I think we need more. Sorry, Kiran, I cannot give you the floor. We really are over time and we still have presenters, and with respect to their preparation, we need to give them the floor. Thank you. So the next will be Yongen.
Thank you. This is Intelligent Network Management using Reinforcement Learning. My name is Yonggun Hong. I'm working for ETLI. For this lab and for this slide, Korea Tech, the university, and the Korea Telecom help us to prepare. So thank you. And this is the third version. So we have a one time to present in last 99 meeting. So it is the second time to present. Yeah, so in this lab, we want to utilize the reinforcement learning. I show you what's the reason, what's the motivation. And nowadays, the deep learning are integrated to RL. So we are also follow that approach in our research. Yeah. Why we want to use the reinforcement learning in network or network management? There are two reasons. The first reason is the decision problem. As you know, the supervised learning is suitable for single decision, for example, image recognition, but in real world, in network, it is not composed of the single decision. For example, multiple network nodes or multiple links and multiple constellation are existing in the real world, in a real network. So in the sequential decision, we believe that the reinforcement learning is more suitable to solve the problem. And the other reason is the data. As you know, in supervised learning, it's based on the lots of the data. So, and it learned by example, that is data. So in the image recognition, we can study and we can teach what is apple, what is orange. But in the real world, as Pedro said and Song says that it is not possible gathering data. So if we deploy and if we solve the problem, we cannot learn by example. So another alternative is learn by experience. That is the interaction. So tasks are implicitly given through the reward. So in this draft, we show three possible network scenario with RL. The first one is the intelligent traffic management. The other is to network prediction. The final is the routing enhancement. So in this time, we show our ongoing research work for the intelligent traffic management. Yeah, that is, so it is the edge-based intelligent traffic control system using DRL. So I don't know you are familiar with the rotary inverted pendulum system. So our goal is to raise the pendulum, the pole, in this way. So to do this, there are two input, two states. That is a pendulum angle data and arm angle data. And these data are delivered to this edge component. So in this machine, we run the DRM module, and the result, the action is to motor power setting data. So, and then this motor power tries to raise the pole in this way. So yes, so this for connecting this system, we use the wire connection, the Ethernet. So there are no problem. So, but in real world, it is not the same easy. So make similar the real world, we try to make the both traffic, and then we try to solve the both traffic with traffic management. So nowadays, we are industrial IoT service, that is the rotary inverted pendulum system, and the edge computing, intelligent control system. We are success to integrate it. So our remaining work is to integrate the other part, traffic management. Yeah. So we show slightly our simulation environment. We use the open AI GRM. So the early definition is like this. And we use three network model network algorithm, the DeepQ network, A2C, and A3C. So as I said that there are two angle and one the motor power, and the reward formula is like this. So you can find the detailed information about this, the open source. Yes, I skip. So it's the result of our simulation. So as you can see, nowadays, the better than DeepQ network, the A2C is a more successful result than DQN. So the remaining work is to integrate A3C module in our test bed. So it is our final phase. So we, you know that we spend much time in IETF, IRTF to deploy network machine learning. But for example, IDNet and network machine learning RG. But nowadays, the Nmrg is the best place to handle that issue. So we want to share and discuss and collect and learn how to deploy machine learning in the network and the network management. So to do this, the first thing is to, yes, so many persons ask to me, what's the reason to deploy machine learning in network? Is it only research, or is it any other benefit? To answer that question, we try to we want to simulate the real world. That is the industrial IoT. That is similar to the smart factory area. And the other is that where is the best place to deploy intelligent function in network area? In every network node or one or two network node, that is the edge node. The reason why we ask that is that if the environment and the problem is too complex, then we cannot the problem. The simple is the best. So we believe that if we deploy network machine learning network function, the smaller is the more better. And the final is that we show DQN, A2C, and A3C. There are lots of the new or existing algorithm or network model. So we want to deploy and really deploy this algorithm in the network area, and want to check and want to find their possibility or this feasibility. So any other remaining works. That's what I wanted to show. That's all. Thank you.
Very quickly, please.
So one of the hallmarks of any deep learning algorithm is that it is based on learning from data representation as opposed to task-specific algorithms. And I'm missing where the deep learning is in your examples.
Yeah, okay, can
You have really not much time. Bing, can you come for the next presentation?
yeah, I show you
I
that.
can answer, but we have to be very quick. Please.
Okay, then.
No, you can answer very quickly, but
So, existing RL is takes much time to calculate the state and the action because we tested in the 1,000 times. So to solve that problem, not only RL we want, but also the DRL is more suitable to solve the problem. So let's go about. Thank you.
our next speaker is Bing Liu, which will give us a presentation on levels of autonomous network technology related to the networkless roadmap draft.
Good afternoon. My name is Bing Liu from Huawei. This work is still in the very preliminary stage, so we just kick out some very rough ideas to attract your attention to get more feedback. So as we know, the network OPEX is always a challenge in the industry. Now, there are always new technologies emerging to deal with the problem. For example, the SDN for the autonomic service delivery, and the new emerging intent-driven network, which we will have a dedicated discussion on Friday in Nmrg. And also, we had many effort on how to utilize artificial intelligence or machine learning technologies for automatic control loop. So we were wondering, is it possible that we can draw a map to illustrate how we can get to the ultimate goal, which is defined as networkless in the draft, which means in the ideal way, in a perspective of an administrator, there's just no network at all. So that's a word, networkless. Okay, so we all know in the autonomous car industry, there are very well accepted levels from totally manual driving to totally autonomous driving. So it's quite natural to think about how about we have a similar levels in how to autonomous drive the network. Oops. So far we figured we need two dimensions to this very comprehensive issue. The one dimension is from the operator's perspective, what's the final effect? For example, there are several aspects. The self-organization, which basically related to various kinds of plug-and-play technologies. How to get connected with a network management system and how to build agencies autonomically, etc. And self-configuration, how to make the parameters automatically be configured. And self-optimizing, we have various technology to make the traffic in a more efficient way. Self-diagnostic and self-healing is about the fault management. Another dimension is the network system itself needs some key capabilities to support the the final effect. There are mainly three areas. The first one is about the measurement. We call it a network perception. And also the telemetry and the network visualization technology all belong to this area. And we also need more sophisticated decision and reasoning mechanism, and the AI and machine learning plays a very important role here. And we also need the operation interface to evolve as well, from the primitive device API to maybe declarative API. So we come up with this table. I'm sorry for the readability, and I don't have time to go much in details. I just pick maybe a couple of examples. For example, for the self-organization, the level, sorry, I only include from the level 2 to level 5, not the level 1, because level 1 all about something already widely used in the industry. And from level 3 to level 5, that's something we just imagined whether the technology will go in this approach. For example, for the self-organization, maybe the next step should be the network can figure out how to make domains by itself without human intervene. That's only a very simple example. For the self-configuration, maybe the next step is the network element can compile some detailed configuration by itself, rather than every single detail will be calculated in the centralized controller or network management system. By the way, I have several hard copies of this table. So if you're interested, please come up to me. Okay, so we really want to hear from you whether this kind of work is valuable to have such kind of levels of the autonomous network. And we already have two dimensions, from the perspective of operators and the key capabilities of the network itself. So is this reasonable or something missing? And for the self-organization, self-configuration, etc., we want to know whether there's also something very important missing in the table. Okay, so this work cannot be done by only a few people. We do want to define it by ourselves. So the goal is to attract discussion, attract contribution, so that we can reach consensus in the industry. Okay, I think that's all.
We have time for some comments or feedback.
Developers. I think that in general, I have not had time to go in detail in the document or whatever is the first news I have about it, I must confess. But I think that there is a clear interest precisely in what this group can do as a research group in providing precisely, sort of a theoretical foundation of what network management should become in the new era. And I think, I find that this is valuable as a research activity. Let me say, I don't think that any kind of a pure real standardization could come out of this. But on the other hand, it could be able to provide foundations for further standardization. So I think it's interesting. In the spite, let me say, I don't know exactly about the 2D dimensions, etc. Something that I think we would need some further thinking. But as a first move in providing this new theory of management, if you like, is something that I think it's interesting.
Thank you.
Dan Drutzer. I think I agree with what Diego said. It can be useful for research purposes. At the same time, I believe this is already happening. I mean, we already have SON self-organizing networks in 3GPP, and it's actually implemented and used. And so I think if there's anything that can be done is narrow down the scope to something that is manageable, understand exactly what is that self-ish aspect within different domains of network management, and then that becomes something that is more coherent to look at holistically. But I think it needs to be tackled on a kind of a domain by domain basis, because that's what gets traction.
Okay.
But yeah, I mean, ideally you would have these capabilities, but they don't happen overnight.
Okay, thanks.
Okay, thank you. We continue with the next presentation, which will be from Jefferson remotely, and I think it relates to some aspect of this presentation. We can have a conclusion after that. Okay. Can you hear us?
Yeah, yellow hand. I'm hearing you.
Okay, you're online. Please go ahead.
Okay, so good afternoon. I'm trying to be concise, and I think that this presentation can be very short. So next slide. Next slide. So as we are talking in Nmrg and the ANIMA working group, there is a minimum set of properties that we conceive as necessary for an autonomic system. And these properties, there are different kinds of definitions for these properties, but usually we can talk about that network must be automatic, adaptive, and aware. So this is translated into different definitions such as self-chop, MapK, and others. And we use this kind of research is usually addressed by the network management area. So for example, in the conference such as IEM, NOMS, and CNSM. And in IETF, and I'm going to talk about this, maybe the correct form for that is the Nmrg. So next slide. So as a perspective, this the first mentions in autonomic networking, they occurred in 2005 and 2006. So there are several antecedents for that. For example, the artificial intelligence in network management, which there are several research activities in the 90s, then self-organization networks and declarative policy and so forth. And there are also several papers, and some of these papers were written by contributors of Nmrg, such as John and other people. Next slide. So there is this, we can talk about the research scope for the autonomic networking, considering different kinds of technologies and the perspectives and approaches for that. So for example, artificial intelligence, policies, machine learning, and some of these topics were addressed by the previous presenters in this meeting. So I believe this kind of something that we can agree on that. And this the research spans in the whole FT spectrum. So this can be applied for wired and wireless network and fixed and mobile and so forth. Next slide. So the autonomic networking movement, it got a lot of momentum around 2007 and 2009. So there are lots of papers on that and an editorial in the Communications Magazine journal, and other interesting and influent papers were published at that point. And also there are some projects that started to address this property known as the autonomic networking ones. Next slide. So just to mention, there are lots of projects, especially projects in the European Union, considering autonomic networking functions and properties, and some of these projects, they use the term autonomic networking, and others, they use some properties that are commonly associated to autonomic networking, but they didn't use the name autonomic networking. Next slide. So there is a decrease in interest in autonomic networking, considering academic research perspectives around 2011, 2013, and there are some reasons that we can cite for that. For example, there are at that point other technologies that were gaining momentum, such as SDN and NFV. The researchers started to use different terms for autonomic networking, such as cognitive networking, intelligence-driven network. So the terms, they changed a little at that point. And there's also something that I think that today is still a problem in that area, in this area, which is the lack of successful deployment case. So, for example, there are a lot of frameworks and tools and the research efforts on autonomic networking, but it's difficult to point out, especially in that point, successful deployment case. And at this point, I also started some work on standardization, for example, in NTSI, and also in the IETF with the ANIMA working group. Next slide.
You have to come to the conclusion, the person.
Okay, next slide. Maybe we can go to the next slide. Next slide. So at least at one point, there's the ANIMA working group, and at the organization of the working group, when the chairs were organizing the charter for the working group, there is this definition that the points or the topics that are outside the charter can be encouraged as an individual submission, but more important as Nmrg submissions. Next slide. So there are potential application areas for this, and considering the areas that are not addressed by the ANIMA working group. So, for example, high virtualized and programmable infrastructures, and there is this Nmrg Internet Draft on some of these kind of infrastructures. There is this application on 5G and IoT and smart something. Also, it's important to have a better link with real-world operations, for example, RIPE, Nog, and other stuff. And also, it's important to understand if there is some effective deployment and the reasons for the lack of wide-scale deployment on autonomic networking. Next slide. And I'm trying to be very fast. Sorry about that. So the question is, there is a need, interest, or energy for Autonomics 3.0 in the Nmrg. So if the answer is yes, and I believe it's yes, I propose 4 efforts on that. And the first one is to pursue the some work on intent-based networking. And I believe that the next presenter, I think it's Alex, and he will talk about that. And also, I think it's important to have some work on AI and ML for network management. That there were also a presentation on this topic. Also, it's important to have an integration with other network automation approaches, such as zero-touch network and service management. And also, I think maybe we are in a point that it may be interesting to revisit the 7575, 7576, which are the RFCs that bootstrap ANIMA working group. So maybe we can revisit these RFCs, for example, thinking what is out of ANIMA scope in a long term. There will be a recharter on ANIMA, I believe, in November. So maybe we can, you can look at these documents and in the new ANIMA charter and see, oh, maybe there is some gap that we can address in Nmrg. So, I mean, I think that's it. Sorry about that.
I mean, Jefferson, also we are already over time, and you may risk to be cut. Dean has a comment, and I would also like to have a concluding comment.
I'm a big proponent of autonomic networking. I disagree that we have to go already to autonomics 3.0. We have a lot of work to do in the current framework, and my main issue is these days we still have one problem. All the exception handling in networks is still done by the human operator. We have to figure out how to automate the exception handling from a service level perspective, from a network service level perspective, instead of just focusing on the device. And if we can lay some foundation on which we can build the next levels on top of that, that would be great. But we have too many holes in the lower layers to go to the, to the next levels.
Thank you. John?
John Strassner. So I broadly agree with Dean. As you know, I'm a big fan of intent networking. I'm working on it actively. I think the biggest problem with going to Autonomics 3.0 or X.Y is that everyone forgets about knowledge representation. And this is a fundamental requirement for any serious AI practitioner or researcher. It's also called knowledge engineering. What Dean was just talking about has been called the qualification problem. So for any common sense rules that you want to encode, there's a huge number of exceptions, right? So how do I make a generic statement and then qualify it to be applicable? And that's certainly present in networking. So without better knowledge representation mechanisms, and not just ontologies, right? But I mean, ontologies, most IETFers don't even know how to spell the word, let alone what it means. So we need to make a focused effort in knowledge representation. And as a general thing, yes, deep learning's important and machine learning and blah, 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 but they're so generic that we're just going to spin our wheels and not do anything.
I think
End of rant.
I'm speaking more as a contributor also to this effort with Jefferson and Lisandro, is that the message you wanted to pass is we acknowledge all the body of work that have been done in autonomic networking, cognitive networking, whatever you call it. But there may be stuff that we still need to address. And I think collectively, as Dean mentioned, John, and maybe others with the previous presentation, we need to identify specific areas, specific domains where we want to concentrate activity of this research group to say, there are still things to do on that that could help the research and could help eventually also standardization. So it's just kind of a call for get together and identify those areas together. So, we are over time. We need to close because there will be another working group after that. I talked with Alex, so he's not. It's okay that we skip his presentation. Thank you for your attention. Thank you for staying with us, even with the power outage. Thank you for the remote presenters. It was not easy to understand what's happening. So we have still a session after this one, which will be a more general discussion about networks and AI. And we also have this dedicated meeting tomorrow on intent-based networking. Thank you very much. And don't forget the blue sheets. If you have not signed it, we can still have time to do that. Can I also, yes, see the lady for the minutes. Thank you.
I'm